Hey everyone, welcome back to Chemistry 1, where today's topic is going to be about compound percent composition. Really quick, please like this video and subscribe to the channel and share this video with a classmate or even one of your teachers so they can kind of see what's going on in these videos. All right, so percent composition by mass is the percent by mass of each element in a compound. I have down here a sample arbitrary compound that I made up called ABC. This is not a real compound, but it is to illustrate that in a compound, you're going to have multiple elements that are put together. So an element is by itself. Those are the items that we find on the periodic table. And you get a molecule where two or more of them combine chemically, and they each have their unique molecular formula. And the theory behind compound percent composition is that each element has a percentage of composition of the whole. So A has a percent composition of ABC, B has a percent composition of ABC, and C has a percent composition of ABC. So in order to find that, there is a formula that we need to follow. And I'm going to unveil it here. And that formula is that you're going to take N, which is the number of that element that is in the molecule. So for ABC, it's 1 for each. If A had a subscript of 2 here, then let me write that down. If it had a 2 here, then when you would find the percent composition of A, it would be 2. So that's what this N means in the formula. Let me erase that too really quick. Okay, so then you have N that is going to be multiplied by the molar mass of the element, which you'll be able to find in the periodic table. And it's actually, yes, the molar mass of the element. And then you're going to divide whatever this top number is by the bottom number, which is going to be the molar mass of the compound. And then you're going to multiply it by 100 so you can have a percentage. You're generally going to have 2 scenarios as far as solving problems. And those scenarios are that you'll start with the element's molecular formula, which has the unit of grams, and then you are going to find the percent composition of each element in the molecule. An example of that is using this, because even you may not be given grams in the sense of you have 50 grams, 100 grams, but what you will be given is a molecular formula. And from there, you know the grams of their molar mass of the element and the molar mass of the whole compound. You can find that using the periodic table. So that's why in one of the scenarios, this first one I have written down is you'll start with grams and then you'll end in percentage. Again, this formula ends in percentage. And then the second scenario is where you'll have the percentage composition. So you'll have a percentage given to you or stated for you. And then you are going to kind of go backwards and find the exact quantity of an element. And then your unit will be in gram. So those are the 2 main scenarios you will find. And don't worry, we will go over some examples to get you familiar with it and comfortable as well. So as far as finding the element percent composition in a molecule, there's a strategy that I like to follow. The first part involves filling in the formula for each molecule, and that is this formula that I'm talking about. And as you see here, we'll do an example of water, and I semi-prepared the formula that we were given to do these types of problems, and we're just going to plug in the numbers that we know from the periodic table. The second thing is that we're going to calculate the formula to find the result of that specific formula for that element. And lastly, we're going to check our work by making sure all the results add up to 100%. So let's practice by doing. We have an example here of water, and water is composed of hydrogen and oxygen. So according to the formula, we're going to do the number of, in this case, we're doing hydrogen first, the number of hydrogen atoms that are in the molecule of water, and we're going to multiply it by the molar mass of that element. So there are 2 atoms of hydrogen, and then the molar mass of hydrogen is 1.008 grams, and then the molecular molar mass is 18.016 grams. Now, this part you have to compose by using the periodic table. For time, I'm not going to show you how I got this number, but I will put a link below in the description of a video that I talk about that topic of finding the molar mass of a molecule. All right, and then we're going to do the math over here, and then we're going to multiply 100, and we're going to get 11.190%. Now for oxygen, we're going to follow the same process and fill in the formula and calculate it to solve. Oxygen only has 1 atom in H2O. Its molar mass is 16 grams. And then we're going to use the same molecular molar mass, which is 18.016 grams that we get from the periodic table. And then also there's going to be a link in this video's description with another video going over that topic of how to find that. Multiply all of this on the left times 100, and we will get 88.810%. Now, checking your work. In the beginning, you'll want to do this all the time, but you will also be able to kind of check, does this equal up to 100? But we'll add them all together, and this does indeed equal to 100. So this is an example of going from grams to percentage in that first scenario I was talking about. Now we're going to go over the second scenario. So here we're going to be finding element quantity when have a known molecule quantity. My strategy here that I like to do when I'm outlining this problem is we're going to determine the element's percent composition from the molecule's formula. And then we're going to use the element percent composition to find the element's quantity. So in the example that we have here, we have 3.71 times 10 to the third grams of magnesium oxide. And we want to know how much magnesium it contains. So since we're just talking about magnesium, we want to find the percentage composition that magnesium has in this whole molecule of magnesium oxide. So I am going to go with magnesium and find its formula. So there's only 1 atom of magnesium in magnesium oxide, so it's 1 times the molar mass of magnesium, which I find by looking at the periodic table, and it's 224.305 grams. And then I'm going to divide it by the molecule of magnesium oxide's molar mass. And using the periodic table, it's 56.305 grams. Then we're going to multiply all of this by 100. And we end up with 43.167% of magnesium. Alrighty, but the question is asking us how much magnesium is in 3.71 times 10 to the third grams of magnesium oxide. So this number is of the whole thing, but we just found out that this number is made up 43% of magnesium. So we have to find out what is 43% of this number. So that in turn, we're going to go 43.167%. We know that in decimal form, that's 0.43167. We are then going to find out what 0.43167% of 3.71 times 10 to the third grams is of the whole molecule. Magnesium oxide. Whatever our answer is going to give grams of magnesium. Once we do the math, it's 1.601 times 10 to the third milligrams. Theoretically, I want you guys to connect that this is the whole, and since we previously found out that magnesium makes up 43%, we just found out what 43% of the whole is, and that's the number that we end up with, and that amount is how much magnesium we have in the actual molecule. I have linked a couple videos of practice problems. The first one is the easier version, and the second one are the more difficult problems that are either longer, involve fractions, involve combining like terms, and so forth. So I will see you guys in the other videos linked below.